Aurox is essentially an applied optics company building specialized three-dimensional microscope imaging instruments. The extra things that we need for the Aurox product to work are clearly the conventional microscope, but also a CCD camera to capture the image. By going back to the real basic physics of how a microscope forms an image, the kind of thing Ernst Abbe understood at the end of the 19th century, and ignoring all the recent work, one can really build a very simple instrument to provide three-dimensional imaging inexpensively, and hence fits a niche in the microscope imaging market. With all optical microscopes, if one looks at an image, a high-resolution image of, say, a biological specimen, which will be a three-dimensional specimen, one ends up with a very good high-resolution in-focus image of the part in the focal plane with blurred bits above and below. And the whole idea of the Aurox product is to get rid of these blurred bits. We modify the illumination of the microscope so that we project a pattern of lines onto the specimen. It's then a matter of clever optics and computer processing to remove the parts of the specimen where there are no lines. It's then a matter of removing the lines from this thin section near the optical focal plane, and that will reveal a thin, in-focus optical section of the thick specimen. We then physically focus through the whole thickness of the specimen, recording these thin sections at each plane, and then we replay in the computer to have a wonderful three-dimensional representation of the whole object. Most people have a conventional microscope in their lab, and so what we are trying to do is to add functionality to that microscope to provide the three-dimensional imaging. So I'm tremendously pleased that by our work in optics, we are able to allow people in the biosciences to really explore the structure of living cells.